the common denominator. So what do you want to multiply by? Yeah. So if you multiply by 2x plus 1 squared, you end up with 2x plus 1 squared minus 2x plus 1 minus what? Yeah. And it equals 0 because 0 times anything is 0. At this point, what are you forced to do? What do you have to do? Yeah, you're going to have to distribute and multiply it out, exactly. So you end up with 4x squared plus 2x plus 2x plus 1 minus 2x minus 1 minus 1. And at this point, what I like to do, I'll zoom in a little bit, but I like to just cancel. What are the easy things to cancel? Those are gone, right? Those are gone. And then what are you left with? 4x squared plus 2x minus 1 is equal to 0. What method should you always consider when you have a quadratic in standard form? Yeah, you consider it at least. Everything is factorable, but it's not always easily factorable. Does this look like it's easily factorable? Yeah, let's just go to the quadratic formula. What's the a value, Rachel? B, C, -1. Be careful. So b squared minus 4ac, what's that called? So we have 2 squared minus 4 times -1. And this is by far the most common mistake, is missing that second negative. So this is going to be 4 plus what? Yeah, it equals 20. 9 out of 10 times people do that fine, but 1 out of 10 times people do, oh, 4 minus 16, right? It's not. It's 4 plus 16. So what do we have for our final answer? Well, semi-final answer, x equals -b plus or minus the square root of 20 all over 2 times a is 8. What's the big thing we need to simplify there? Root. Yeah, what's it become? Plus or minus 2 root 5, right? Because you have to pull out a 4. But then you have 2, 2, and 8. What does that become, Katie, if it's 2, 2, and 8?
2, 2, and 8.
Yeah. 1, yep. Exactly. So it's this right here. This would be your final answer right here. That's great, 2 answers. Now, when you get an answer like that, what does that tell you about how easy it was to factor? It was very difficult to factor. You would not be able to factor this normally. In fact, actually, if I asked you to factor this in a later class, you would do the quadratic equation and then use this information to go back and factor it, which seems to be pointless, right? But I'm just telling you that down the road, there are some times when you really want to get the factored form. Okay, what second number do you want to do? Any others that you want to do? 27? Let's do 29, shall we? Let's do 29. I like 29. You have a trip, right? Was it Jackson? And you have, anybody know where Manteca is? I don't really know. I mean, it says California. Yeah, I just don't know where some of these are. And then you have Lodi.
Jackson North.
I think it's north. I mean, I think this is Central Valley, but who knows? I should just look it up. It's amazing what the internet could tell you instantaneously. This is 40 miles, and this is 40 miles. So I'm just drawing the picture that they've given me. But what does it tell you? It tells you that the first leg of the trip, and then the second leg of the trip. What does it tell you about the second leg of the trip?
10 miles per hour.
Faster, right? This is number 29, exactly. So what's the main formula we're going to use for this? We're relating 3 things together. What's the main formula? Distance equals rate times time. Let's call this trip A right here, and let's call this trip B. So we have trip, distance, rate, and time. There's trip A and trip B. What's the distance for trip A? 40. What's the distance for trip B? Do we know what the rate is for the first trip? Sure. Let's just call it R just because it's rate. If that's R, what's the rate for the second leg? R plus 10, right. Now this is where you have to be careful here. We could just write T and T. We don't really know, like time 1 and time 2, but we know that distance is rate times time. So what does that tell us time is equal to? D over R. So can you tell me when you apply that right there, what do you end up with? 40 over R and R plus 10. Now that's the chart. That's a great thing to set up, but it tells you that the whole trip took how long? So this is total. We know it's 88 minutes, right? So we can write an equation now. Can someone tell me what equation I can write right now? Jacob.
40 over x.
Or R, yep, plus.
Plus 40 over r plus 10.
Yes.
Equals 88.
This is about 95% correct, but it has a critical flaw. If you solve this, it will not get you the correct answer. The rate. What are the units on the rate on this thing? Miles per hour. This is in minutes. Is that a problem?
Yes.
You need this to be in hours. What's the easiest way to turn that into hours?
1.2.
Over 60. 8. If you want to go to minutes to hours, what do you divide by? 60. 90 minutes, how do you get to hours? You divide by 60 to get 1.5. This right here is the equation that you need to solve. The big challenge with this one is that the numbers are big. That's it. Does the method change? No. Before you go about solving this, simplify the easy stuff to simplify. When you're looking at that, can you tell me one thing in there that's really nicely, you can simplify a little bit to help you out a little bit? Yeah, this is what, 44 over 30, but what, 22 over 15. Now, does that help a tremendous amount? Not really, but does it help a little bit? Yeah, it helps a little. Now, at this point, when you have 22 over 15, there's different ways to go about solving this. Unfortunately, there's no way around the fact that you're going to have big numbers. There's just no way around it. Let's multiply by the same thing. Can you tell me what I should multiply by? R times R plus 10 times 15. If you multiply by that, all of the denominators are going to go away. Are we going to end up with big numbers? Yes, but are all the fractions going to go away? Yeah. So you end up with 40 times what first? The R cancels, leaving you with just what? 10 times 15. And then you have 40 here, but it cancels the R plus 10, leaving you with just R and 15. And then over here you have 22. 40. Thank you. Is that a key thing? Yes. What do you have here? 22 times R plus 10. Now, we got rid of all the fractions. This is a quadratic, but what form do we want it in? Standard. Is it in standard form? No. So when you do this out, the big thing is no individual operation in this is very hard, but when you do a lot of easy operations, you tend to speed up, and then you make really small mistakes, and then your life is very sad. Because if you make a small mistake with big numbers, it blows up real bad, and you're not happy about it. I will tell you that these numbers get so big that I would never give you this without a calculator. You would need a calculator, in all fairness, to do this. But here's what you would do without a calculator. First multiply the 40, and you get 40R plus 400 times 15 plus 600R plus 22R squared plus 220R. I've just multiplied out. What's 15 times 40?
600.
Yep, 600R plus, 6,000 plus 600R equals, sorry, that's an equal sign. Thank you. I was like, where did it go? These are still big. Is it closer to standard form? Yeah. So what do you get on the left here? You get 1200R, right? Plus 6,000 equals, we're getting closer. Are we there yet? No, we are not. We need to, let's move all of this over to the other side. You can make it, the only thing you could do, they're all even, right? So you could do 600R plus 3,000. You know, take what you can get, I guess, right? Plus 22R. Unfortunately, you might want to divide by 11, but the problem is...
That's what I was going to say.
100. Look at that. Basic math. Failing Mr. Seamon. Okay, 110R. That better? Okay, so at this point, you might want to say, oh, divide by 11. Is 600 divisible by 11? Not nicely. Let's take all of this and put it on the other side. So you end up with 0 equals 11R squared. And how many R's do we end up with? Minus how many? 490R minus what? 3,000. Now here's the thing. Even if that was factorable, do you really want to play around with it? No. So what should you go straight to? So A is what? B. And C is negative 3,000. Now here's the thing. Does the quadratic formula care about what numbers you put into it? No. Are these big enough that you need a calculator? Yes. So if you did this, still do the discriminant, and Dev, you can do this for me. You end up with negative 490 squared minus 4 times 11 times negative 3,000. Can you do that for me, Dev, and just tell me what the number is? So T plus 2, right, exactly. So, together, so job per hour. What's the job per hour rate if it takes him to do, if it takes T hours to do the job? How much of the job do you do per hour? If you can do a job in 2 hours, how much of the job do you do in 1 hour? Half. If it takes you 3 hours to do a job, how much of the job do you do in 1 hour?
1/3.
1/3. So if it takes you t hours to do the job, how much of the job have you done in 1 hour? What?
Alright.
Listen, I'm going to say it out loud. I'm going to say it again. Hannah, no one else speak. If it takes you 2 hours to do a job, how much of the job do you do in 1 hour?
1/2.
Yes. If it takes you 3 hours to do a job, how much of the job do you do in 1 hour?
1/3.
If it takes you t hours to do a job, how much of the job do you do in 1 hour? Yes. Okay, so what about R here? How much of the job does Rusty? 1 over what? T plus 2. So this is R plus N. How long does it take them to do the job together? 12 hours, right? How much of the job do they do in 1 hour? 1 over 12. But look, we know that Rusty can do that much in an hour, that much in an hour. So what equation can we write? 1 over T plus 2, yep, equals, exactly. And is that an equation we can definitely solve? Yeah, what should we multiply by? T plus 2. Yeah, so what do we end up with? We end up with T times 12 plus T plus 2 times 12 plus equals, need an equal sign in there, equals what? T times what? T plus 2, because the 12 goes away. Is that a quadratic? Sure. Is it in standard form? No. So you have to distribute. Is this actually a lot nicer than the one we just did? This is a heck of a lot nicer. We want it equal to 0, right? So how many t's do we have? We have what, 24 of them? We have 12, so we're going to have 0 equals t squared minus, how many t's on this other side are we going to end up with? Yes, 22 minus 24. And at this point, what should you ask yourself? Can you factor it? Does it maybe, maybe kind of, but it doesn't look very nice, does it? Because what are the, I mean, 24 is 12 and 2, but that doesn't make 22. 6 and 4 doesn't make, so what do you really need to use? A equals 1, B equals what? And C equals 24. So we end up with b squared minus 4ac is negative 22 squared minus 4 times 1 times negative 24. 22 squared, anybody have that for me? 440, 484? Is that 484?
484.
Yep.
Yeah.
Plus 80, 96. Is that right? Yeah. Can you check that for me?
Plus 86 or 96?
It's 96, right? Or 90, so 570, I think it is. Is that correct? 580, sorry, 580. Is that right?
Yes.
Yep. So what do we end up with? X is equal to negative, what was B? So positive 22 plus or minus the square root of 580 all over 2a, so 2, right? Now the question says, how long to the nearest tenth? When it says things like to the nearest tenth, does that mean you're going to get a nice answer? No. So like, for example, 580, does that simplify very well? No, it's not asking for the most simplified. It's asking you literally to do this on your calculator. Here's the thing. Can you tell me, is 580 bigger or less than 22?
Square root of 5?
No, is 580 bigger or less than, sorry, the square root of 580, is it bigger or less than 22? Don't do it, you know it already, because what's 22 squared? 484, we just did that. So 580 is definitely, the square root of 580 is definitely bigger than 22. So when you subtract it from 22, you're going to get a negative number. Now we're solving for a time, right? So we need it to be positive, right? So we're looking for our final time. Final time, I'm using many colors here apparently. Time equals 22 plus the square root of 580 all over 2. Do this on your calculator and tell me what the answer is to the nearest tenth. Don't say it out loud, just do it on your... Okay, so you'd solve that. Excellent. Yes, that's a lot of... I like that. So you got b squared w is equal to kfr over... Oh, just kfr, right? It's gone. Yep. So now what do I do? Someone tell me what... I like that, yeah. So w... Oh, no. Wanted v, right? So v squared is equal to kfr over what? And now what? So v is equal to the square root of kfr over w. You have halfway done. When you take a square root, what do you have to have?
You can't have it in the
That's the second thing we're going to do in a second. What's the square root of 9?
plus or minus.
Plus or minus. Nice. Remember plus or minus? When you take a square root, when you're adding in a square root, you must do plus or minus. So at this point, you said, if someone said it, I think Jacob, you said we don't like, oh, Kelly said it, we don't like radicals in the denominator. This is the same thing as plus or minus the square root of KFR over the square root of what?
W.
We don't like that though, so what do we multiply by?
W over W.
Square root of W over the square root of W. So what do we end up with? Plus or minus the square root of KFRW over W. So your cool final answer would be this right there, but it had to be plus or minus. That's it. So you ready for one that's a little bit more fun? No? Huh.
Oh,
It's okay. Remember, it's syncing with your notebook, hopefully. How about you try this one for me? Ready? I'm going to just change the letter here. I don't like using s. Equals 2t squared plus kt. And I want to know what t equals. The hint I'm going to give you is the following. Everything except for t you treat as a constant. So it's not the variable p, you treat it as like a number p. So in that case, only the t's are variables. In that case, what kind of equation is this? Is this a line? No. It's a what? It's a quadratic. So how did we solve quadratics? What was our first thing we did? No. Before we factored, what did we put it in? So put this in standard form and see what you can do with it. Put it in standard to turn this into standard form. Yeah, subtract p. So it was 0 equals 2t squared plus kt plus what? Oh, minus, right? Minus p. So now it's in standard form. You ask yourself, can you factor this? And you go, I don't really want to factor it. So what are you going to use? Tell me what a equals, Katie. Rachel, tell me what b equals. And Lauren, tell me what c equals. Yeah, so what can you use right now? Yeah, so b squared minus 4ac, what does that equal? K squared minus 4 times 2 times negative p. So you get k squared plus what? 8p. Oh, so what does this mean? T equals negative b. What's b in this case? It's going to be negative k plus or minus the square root of k squared plus 8p all over what? 4. 2 times 2, yeah. Now at this point you might think, oh, should I simplify this? Is there anything you can simplify? No. Careful. No. Because look at the square root. My guess is you might want to make that k, right? But why can't you?
because it's the P.
It's a plus 8p, right? It's a plus. So at this point you would be done. You have used the quadratic equation to solve it. That's it. If we had a value for p and we had a value for k, could we get a number for t? Yes. But that's not what it's asking. We are done.
If there was a value for 1, could you?
Yeah, you would just
if
still.
If it was like 2 squared, could you pull that?
Sure, you could, but you'd still have one of the other letters in there. You still have one of the other letters. Okay, so let's add a little bit to this. I'm gonna add a little bit to this. Yeah, very good. So you have this, and one car is going north, right? And one car is going left, which is west. And what's the distance between them? 100 miles. Do we know how far the distance is here at the base of the triangle? No. What's the relationship between the height of the triangle and the base of the triangle, Katie?
The height is, like a variable plus 20.
Yeah, b plus 20. I called it b. You could have called it something else, right? I called it b for base, right? What type of triangle is this? We want to know how far they've traveled. We want to find b, so we can find what b plus 20 is, right? But this is a right triangle, so what formula, what theorem can we use? No. No, it's not. It's a right triangle, so we know that one side squared plus the other. So b
plus 20 squared plus b squared.
Equals 100 what? Exactly. There it is. Yes. Yes, it is. So you've squared the two legs. You squared the two legs. I can't select it. It won't let me for some reason. I don't know. There's this and that. Exactly. So how would you solve this?
2b squared plus 20 squared.
So you have b squared plus, you have to multiply it out, right?
Yeah.
B squared plus 20b plus 20b plus 4. Yes, you do. And what's 100 squared? 10,000. So again, these are bigger, but this one's not as bad as the other one.
Why do you have to FOIL that one?
Because you need to get it to standard form. It's not in standard form yet.
I have a question.
This right here is not standard form right there.
Yeah, but like how would
Where did that come from?
Just factor the squared into it.
You can't, because this is b plus, remember b plus 20 times b plus 20. So at this point, yeah, go. What was your question, Mark?
Why
Yeah?
can't you just square root everything.
You can't because 3 squared plus 4 squared does equal 5 squared, but 3 plus 4 does not equal 5. That's why. You have to square root both sides. So we clean this up. How many b squareds do you see? So you have 2b squared plus 40b plus 400 equals 10,000. Is that almost in standard form? What do we need to subtract?
10,000.
So 2b squared plus 40b minus 9,600 equals 0. What can we divide everything by just to make our lives a little easier? 2. So you have b squared plus 20b minus 4,800 equals 0. At this point, you ask yourself, is it factorable, but do you really want to spend time factoring this? It's not bad. How about it?
Yeah, because 20 would go in, or like that would go
Yeah.
in that really nicely.
It would. I'll just tell you what the factored form is, just so you can get it. It would be b plus 80 times b minus 60. Because what's 80 plus negative 60? 20. What's 8 times 6?
48.
Did you see it up there, everybody? It's going to be negative and 2 zeros. It's kind of hidden. It's hidden a little bit. So what are the two answers here? B is equal to negative 80 or what? There's only one answer, though. Which one is it? Y. Can't have negative distance. Exactly. Very good. Very